So as strange as it seems, I'm going to do the contains method first because that's going to act as the guide for doing the other methods. So we're going to go ahead and do a standard return false over here, just to silence the compiler. Okay. So now, as I mentioned, there are basically just two tree algorithms that we have that we need to use. The first is basically iterating over all the things in the tree, which is what toString is going to be. And the other algorithm is search left, search right, search left, search right, zig and zag through the tree until you find the appropriate spot. Right? And each time you do a left or a right branch, you're going to be splitting your search space in half. Right? So contains item, all these are going to be wrappers for private recursive methods. So Boolean contains is going to actually going to call a private method, which we'll write like this: private Boolean contains node e root and e item. And what this function is going to do is we're going to ask if the root of this subtree contains this item. In other words, does this subtree, which has this node as the root of that subtree, contain this item? Right? So we'll return contains this.root and item. So now basically, now that we're looking at it at the perspective of a node, trying to say, okay, do I contain let's look at a perspective from this local root, the root of this subtree. We're asking this tree if it contains this item. We're asking this node, essentially. So what does he know? Well, he knows if he has the item, and then he's got some choices. So he can check if he has the item. He can check his left subtree. Then he can check, okay, is it supposed to be my left subtree or is it supposed to be my right subtree? Okay, and he can do all those checks at once, by the way. Or he can check if he has the item, it's in his left subtree or is in the right subtree, all at once by using the compare to method. So let's see how we can do that. So first, though, we need a base case. And the base case is, what if the root of this subtree is null? What if root equals null? Well, that means that basically we got to a recursive area.
Oh, hi, Laser. Hi. Do you want to interrupt Dad's recording? Yes, you did. Of course you did. Hi.
Wave to the camera. No, don't try to get to my keyboard. Hi. We've interrupted your scheduled lecture for some unscheduled cuteness. Mwah. Hi. How are you doing? Hi. So, by root equals null, we're asking ourselves, okay, if we've somehow got into a tree, remember, a valid tree is a null tree. If we've gotten to a null subtree, well, there's nothing to search, and if we haven't found this item now, we're not going to find it. So that's pretty easy. Whoops. Okay, put you down. Return false. And he's going out to explore some more. Okay. Else. Well, let's figure out what else we can do. What else we can figure out. So if it's null, we can look for the item. And notice how it's the local root and not this.root. So let's see. So if item, so let's actually compare the items it stores. So int comparison result is equal to root dot item dot compare to item. Actually, it's probably easier to do it the other way around. This is actually the trickiest part, which is thinking of, and I just think of it easier this way. So item dot compare to the item in the root. Dot item. And when we do it this way, we're asking, is the item smaller, equal to, or greater than. So you got anything that he shouldn't have? Probably. Sticker.
From your
So int comparison result. So if this result is equal to 0, what does that mean? Well, that means that the two items were equal, so we found the item, so return true, right? If they're equal to 0, then that was the item we were looking for, so just simply return true. Otherwise, well, the root of the tree doesn't have it, so it's either in the left subtree or the right subtree if it's there. Now, we don't have to bother checking if our children are null or not, because well, if we pass them to a null child, this if block will catch it right there. So else if comparison result is less than 0, right? If the item that we're looking for is less than the item in the root, or comes before the item in the root, then that comparison result will be less than 0. That crinkling goes well in my lecture. It goes fantastic with the lecture I'm recording. She crinkled it extra just for you. Okay, so we'll return. So if it's in my left tree, I'll search my left tree, and we can get and we'll just simply return the answer of contains root.left and item. And if it's not to the left, well, and it's not here, then the only other place to check is the right. I'm not re-recording this. All right. And that's all we have to do to check. Now it's got this return false as being x'd out because it's unnecessary here.